qualitative analysis from May-June 2006, variant 3. In this experiment, they have given us 4 aqueous solutions, Fa4, 5, 6 and 7. Each solution contains one of the following: alcohol, aldehyde, carboxylic and a ketone.
So these are the chemicals given.
You are to perform the tests below and from the results establish which type of organic compound is contained in each of the 4, 5, 6 and 7 chemicals. After each test, discard the contents of the tube into 250 cm3 beaker labeled organic waste. Rinse and reuse the tubes for the remaining tests. Tests for gases are on the last page, and then record your results in the table on page 7, where no reaction takes place. Write no reaction in the appropriate box in the table. Now in the next page, that is page 7, they have said, they have given us a table like this: Fa4, 5, 6 and 7, and A, B, C, D, E tests should be performed and written here. So the details of tests are: test A, place 1 centimeter depth of each solutions Fa4, 5, 6 and 7 into a separate test tubes. To each test tube, add a small quantity of magnesium powder or turnings. Identify any gas given off and record the test you used to make the identification. Now let us look at the functional groups here. There are 4 functional groups given in 4 different chemicals: alcohol, aldehyde, carboxylic and ketone. And if they have asked us to add magnesium powder or magnesium turnings, it means this electropositive metal can react with alcohol and a carboxylic acid, where the reaction with alcohol will be very slow, of course, because it's not that much electropositive like sodium or potassium, but it will react quite impressively with the carboxylic acid. So when any metal reacts with acid, a metal salt and hydrogen gas is given off. It means when they have said here identify any gas given off, it means we have to identify hydrogen gas if liberated. So hydrogen gas is tested by a lighted splint that produces pop sound. So let's perform this test now. So let's take all these chemicals one by one in test tube. 1 centimeter depth of this Fa4. When we add magnesium powder in this test tube, we can see not too many bubbles are formed. It means no change. Now let's take 1 centimeter approximately Fa5 and add magnesium powder. So here we have magnesium powder. So when we add this magnesium powder, yes, gas is given off. Put a thumb over the top so that we can collect a bit of gas over the top of the tube and bring a lighted splint here. This lighted splint should produce pop sound. So this is the pop sound, means the gas is hydrogen. Now let's take the next Fa6 solution, 1 centimeter depth, and add same magnesium powder. So no gas is given off, no change. Let's continue with the next Fa7, 1 centimeter depth of Fa7, and when we add magnesium powder, again it shows no change, means no reaction. So when we have performed this test A, the results should be recorded on this page here, that no change in Fa4, A6 and 7, but colorless gas given off, which has produced pop with the flame. Let's record these observations here. So we have recorded these observations here, and from these observations, Fa5 is tentative or alcohol or carboxylic acid, because they both gives hydrogen gas when a metal is added to them. So let's perform the next test, which is test B. Place 1 centimeter depth of each solutions Fa4, 5, 6 and 7 into a separate test tubes. To each tube add a small quantity of powdered sodium carbonate. Identify any gas given off and record the test you use to make the identification. Now, let's concentrate on the reaction that is happening here. If we add sodium carbonate, which is a metal carbonate, only carboxylic acid, being an acid out of these four, will respond to this test. By reacting with an acid, metal carbonates gives off carbon dioxide, salt and water. So carbon dioxide is tested by lime water, which turns milky. It means out of these four chemicals, the one which is giving fizzing, we must pass that fizzing through a lime water to make the judgment that this is a carboxylic acid. Now let's perform this test. Now let's take 1 centimeter depth of Fa4 in a test tube and then add sodium carbonate. No gas is given off. The solid settled at the bottom. It means it's not an acid. Now let's take 1 centimeter depth of Fa5, and remember in the last test we got to know that this has given colorless bubbles with magnesium turnings. It means it could be our tentative carboxylic acid. So if it's a carboxylic acid, we must take this gas which is given off when metal carbonate is added through the lime water. It means if it is a carbonate, if we add metal carbonate and this is an acid, so the carbon dioxide which is given off must be passed through lime water. So this is the rubber bung which has a delivery tube, and we need to take lime water in another tube and we need to pass this delivery tube through this solution which is of lime water, so that if it is carbon dioxide which is given off, it will turn that solution milky white. So in this test tube we will pour the lime water first. So here we have lime water we will take a small amount of lime water in the test tube, and we will put this delivery tube through this lime water. And now, once I add sodium carbonate in this tube, I will quickly put this rubber bung over the top so that the gas given off quickly pass through this test tube. So in one hand, I will put this rubber bung, and in the other hand, I will take this sodium carbonate. As soon as I add sodium carbonate, I'll put this rubber bung over the top. Okay, so as soon as I have added sodium carbonate, I can see the gas is given off, and if this gas is passed through this lime water, the lime water we can see is gradually turning white. From colorless solution, we can see the lime water has changed its color to a bit white. It means carbonate is confirmed, giving off carbon dioxide. Now, let's see, this was the lime water which was colorless, and see the test tube is showing a white precipitates clearly. It means carbonate has given off carbon dioxide with the acid. Now, let's take the next Fa6 1 centimeter depth, and again we will add sodium carbonate. No change, it means no gas is given off. We will do the same test with Fa7 now. 1 centimeter depth, Fa7. When we add sodium carbonate, no change is happening here in this also. It means no reaction in this also. So out of these four, we have just carboxylic confirmed as Fa5. So we have recorded this observation here that only Fa5 has given us fizzing, which has turned lime water milky. So up till these two tests, we can conclude that out of these four functional groups they have given us, Fa5 contains carboxylic acid. Now, let's move on to the test C. Now, test C says place 1 centimeter depth of each of the solution Fa4, 5, 6 and 7 into a separate test tubes. To each test tube, add 1 centimeter depth of 2,4-dinitrophenylhydrazine reagent. Now let me tell you about 2,4-dinitrophenylhydrazine solution. This 2,4-dinitrophenylhydrazine is ideally orange solution, but sometimes it is yellow depending upon the concentration. Now it is used to test carbonyl group. Carbonyl group includes aldehyde and ketone. If the test is positive, this orange solution forms orange or yellow precipitates. So let's perform this test now. Now let's take 1 centimeter depth of Fa4 in a test tube and add 1 centimeter depth of 2,4-dinitrophenylhydrazine. So you can see clearly yellow precipitates are formed. Let's move on to the next Fa5. Take 1 centimeter depth of Fa5 and add same 1 centimeter depth of 2-nitrophenylhydrazine. Now we can see no clear change is happening. Let's move on to the next Fa6, 1 centimeter depth, and add 2,4-dinitrophenylhydrazine in this also. Now we can see clearly yellow precipitates are again formed. Let's move on to the next Fa7 now. 1 centimeter depth of Fa7, and add the same. Now, if we compare these 4 test tubes, we can see this solution has given us precipitates which are orange, and this is not too much changed, and this also has given us the yellow precipitates, and the solution again has no precipitate. It means Fa4 and Fa6 has given us the positive results. So we have recorded this observation that Fa4 and Fa6 has given us orange to yellow precipitates. However, the Fa5 and 7 has shown no change. It means Fa4 and 6 are aldehyde or ketone. So Fa4 and 6 are yet to differentiate. Let's perform the next test now. To the test D, they say, place 1 centimeter depth of each of the solutions 4, 5, 6 and 7 into separate test tubes. Now place 2 centimeter depth of aqueous silver nitrate in a boiling tube and add to it 1 centimeter depth of aqueous sodium hydroxide. This will produce a precipitates of silver oxide. Now this silver oxide is brown in color. Next, they have said use a dropping pipette to add dilute aqueous ammonia to this mixture until the precipitates of silver oxide just dissolve. Do not add an excess of aqueous ammonia. Now, the two statements they have given us here, place 2 centimeter till this, do not add excess ammonia. This is the method to prepare Tollens reagent. And now, what is Tollens reagent? Tollens reagent is one of the reagent that is used to differentiate in between aldehyde and ketone. Now, when we have this result, the Fa4 and 6 are carbonyl, like these two are aldehyde or ketone. So, in order to differentiate in between these two, that which contains aldehyde and which is ketone, they have given us this test. Now, this is Tollens test, and if we prepare this Tollens reagent and we add in aldehyde, this aldehyde solution gives us black precipitates which deposit on the wall and give us silver mirror. So let's prepare this Tollens reagent first, and then we will add in all 4 test tubes. Now, let us prepare the Tollens reagent first. So we have taken boiling tube and we will take 2 centimeter of silver nitrate solution first. Now, in this 2 centimeter depth of silver nitrate solution, we will add aqueous sodium hydroxide, which will give us brown precipitates of silver 1 oxide. So as soon as we add sodium hydroxide, we can see brown precipitates of silver 1 oxide are formed. Now we have to add aqueous ammonia just enough to dissolve these brown precipitates. And instructions in the paper has clearly said that we do not need to add this in excess. So we will gradually add this aqueous ammonia and we will swirl this mixture and we can see this is colorless. It means we are done with this. Now the solution which we have formed is Tollens reagent. Now this Tollens reagent is used to test aldehyde group. Now let's perform this test. So first of all, we will take Fa4 1 centimeter depth and now we will add Tollens reagent. No black precipitates are formed. Let us take Fa5 now, 1 centimeter depth. And add Tollens reagent. No change. Now take Fa6, 1 centimeter depth, and we add Tollens reagent. Okay, so black precipitates are clearly formed. It means aldehyde is confirmed. Let us see in this Fa7 also what happens to a 1 centimeter depth of this Fa7. When we add Tollens reagent, no change. It means out of these four, Fa6 has only given us the black precipitate. It means Fa6 is our aldehyde. So let's record this observation. So we have recorded these observations here, that only Fa6 has shown us black precipitates and rest of the solutions have shown no change. It means we can conclude the Fa6 is aldehyde. It means if it is an aldehyde, so cross this out, ketone, it's not ketone. And if this is an aldehyde, so cross this out, aldehyde, it must not be aldehyde then. It means two of the chemicals which are confirmed so far are Fa4 is a ketone and Fa6 is an aldehyde. So let's record this also. So we have concluded this. The Fa4 and 6 are ketone and aldehyde. And this Fa5 has given us the observations of colorless gas with magnesium powder and fizzing with acid. It means it was carboxylic acid. So let's record this also. So Fa5 is carboxylic. Now we are only left with Fa7, and out of these four, if we have identified aldehyde, carboxylic and ketone, the last one is alcohol, of course. But let's perform the next test, which is test E. And in the test E, they have said, place 1 centimeter depth of each of the solutions, Fa4, 5, 6 and 7, into a separate boiling tubes. To each tube, add a few drops of acidified potassium dichromate to give a yellow-orange solution. Warm the tube gently. Now this potassium dichromate is an oxidizing agent. This is our potassium dichromate solution, which is orange, and this oxidizing agent is used to check alcohol, because if it is a primary alcohol, it oxidizes to carboxylic, and if it is a secondary alcohol, it oxidizes to ketone. However, tertiary alcohol do not oxidize. Now, if alcohol oxidizes, this potassium dichromate changes its color from orange to green. So let's perform this test now and see which of our 4, 5, 6 and 7 makes this potassium dichromate orange to green. Now let's take one by one all these Fa4 1 centimeter depth, and add few drops of acidified potassium dichromate. Now let's wait, and meanwhile we will take the next Fa5 1 centimeter depth and again few drops of potassium dichromate. Let's wait. Fa6 now 1 centimeter depth. Few drops and now the last one, Fa7 1 centimeter depth and few drops of potassium dichromate. Now initially this potassium dichromate is not giving us a very clear test. This is why we will warm these test tubes as given in the question. So we will put these test tubes in this water bath and we will put them in a sequence so that we can see which tube is showing the color change. 4, 5, 6 and this one is 7. So let's wait for a few minutes and see which test tube changes its color from orange to green. Now, if we see Fa4 and Fa5, they have not changed their color significantly, but this Fa6 is clearly green and this Fa7 is also changed to green. It means these two 6 and 7 chemicals are aldehyde and alcohol because these both groups can be oxidized. So we have recorded the test E observation, which shows the aldehyde, which was Fa6 was oxidized and Fa7 was also oxidized. It means Fa7 is our alcohol. Now let's move on to the next part in which they say identify the type of organic compounds which we have just identified. And now out of this identification tests, we need to write here type of organic compound contained in the solution and confirmed by the observations in the tests. So here if we see we have performed these tests, we have to write how we concluded that this contains this functional group. So let's write here that which contains which functional group out of the tests confirmed by the observations. So we have recorded here that these Fa4 contain ketone because of the orange PPT form with 2,4-D NPH, and Fa5 was carboxylic acid because it has given fizzing with sodium carbonate. Aldehyde is Fa6 because it has given us black precipitates, which was in test D, that was Tollens reagent test. And Fa7 is an alcohol because it has given us a positive result with potassium dichromate, that orange to green solution was formed. So here we comes to an end of 10-mark organic functional group analysis question from May June 2006.